Today we're going to learn how to use the law of cosines, and we talked about in the last section how we need the law of cosines to solve the SAS case or the SSS case. So SAS means the angle in between two given sides is given. And to use the law of sines, again, you need to know an angle and the side opposite. Well, you wouldn't know that in the SAS case. And then SSS, you don't know any angles, so you cannot use the law of sines. So I've got three versions of the law here. They're really all the same. It's just saying that you've got your three sides of your triangle, right? So this A here, notice that's across from the angle alpha here. B, beta, C, gamma. So whatever side is over here should be across from the angle here. And excuse me, what was I going to say? So it doesn't really matter how you label the triangle. Just remember that it's, this side squared equals the sum of the other two sides squared. So square each side, add them up, minus 2 times those two sides times the cosine of the angle opposite it. So notice B, then this is A and C, and this is A and C. And then this is beta. If this is C, then this is A and B, and this is gamma. So the formulas are really all the same. It's just like relabeling, different point of view, if you will, in the triangle. So I'm going to show you just a proof of the first one. I already set up the drawing so that the video will be a little shorter, but you might want to pause the video and then copy this down. And then I'll explain the setup a little more here. So we're going to just prove number 1. If we want to prove the other two, we'll just redraw this with, beta in this corner or gamma in this corner. I'm going to start with A. So I got vertices A, B, and C. So this is alpha, beta, gamma, and of course sides opposite, right? So this side has length A, this side has length C, this side has length B. And then I drew the height of the triangle, and I called that Y. Because, and then, this length here to get the the length between this vertex and the height is x, because then I'm going to call that the coordinates of this vertex B. So you go over x up y, that's xy. And then the coordinates of C are this length B, right? That's the length opposite of beta, and the y coordinate is 0 because we're on the x-axis. So that's the setup, and what we want to do is we're going from the point of view of alpha here. So we want to find the length of A using the Pythagorean Theorem and this right triangle right here. So we're going to basically use the distance formula to find the length of A, okay? And then this is all going to come out, as you'll see. So what we need is we need to get x and y out of here. We need these coordinates. We're going to find, difference in the x coordinate squared plus the difference in the y coordinate squared. Take the square root of that, right? So let's say note A equals the square root. The difference in the let's do x first. Difference in the x coordinate squared plus difference in the y coordinate squared. And that's from the distance formula. You could also just use the Pythagorean Theorem, of course, but that's where we get the distance formula from. So the problem here is we need to replace the x and the y in terms of alpha, beta, gamma, or A, B, C. So let's see if we can do that. So what I want you to know is we can use this right triangle here to write the coordinates of this point. This is all based on the definition of the trig functions. The cosine of alpha is equal to x over c. I'm doing cosine, adjacent over hypotenuse. So that implies that x is c cosine alpha. So we're going to replace the x in terms of these because these are parts of the triangle, right? Because we're going to be given parts of the triangle. We're not going to know what x is without plugging it into this formula anyway. And then the sine of alpha, so from here, we go opposite over hypotenuse, y over c. So that implies that y equals c sine alpha. And this is, again, you can use the definition of the trig functions where you take, cosine is the x coordinate over the radius. In this case, the radius is c. The sine is the y coordinate over the radius. The radius is c. So I'm going to replace x and y with these expressions because they include the parts of the triangle. So this is equal to, and actually I'm going to square both sides because notice in the formula this is squared. So if I square both sides, that gets rid of this radical. Okay, so x is c cosine alpha, and I've got minus b squared plus, and y minus 0 is just y, but I'm going to replace it with c sine alpha squared. And when we do the algebra here, you're going to see that we're going to pick up the formula. So when I square this, I need to multiply it times itself. So you have to FOIL, right? So take c cosine alpha times itself, and you get c squared cosine squared alpha. And then our outside term would be minus b c cosine alpha. But then we'd get that again. Here, let me write it up here. I don't want you to be confused if I'm doing too much at once, right? So this is what I'm doing. The c and the cosine kind of run together. This is c times cosine alpha, right? So when you square this, you're multiplying it times itself. So this times this gives us c squared cosine squared alpha, then minus bc cosine alpha, and then the inside two give us the same thing, minus bc cosine alpha. And then the last two will be plus b squared. Negative b times negative b is plus b squared. And then we have this squared will just be c squared plus c squared sine squared alpha. So notice this part here is what we're looking for in the formula. That's minus 2b cosine alpha. So the question is, does this and this give us b squared plus c squared? Whoops, where did oh, sorry, here's my b squared, lost track. So here's my b squared in the formula. Sorry, it's been a while since I've done this proof. So here's the b squared. Well, not that long, but it was last semester. So b squared, and then plus c squared cosine squared alpha plus c squared sine squared alpha. We're going to look at those two in a second. And then these two give us minus 2bc cosine alpha. So notice these, you can factor the c squared out. Got cosine, whoops, that's squared alpha plus sine squared alpha. That's 2bc cosine alpha. And this is our friendly Pythagorean identity that equals 1. And so c squared times 1 is just c squared. And so a squared equals b squared plus c squared minus 2bc cosine alpha. And we've completed the proof of the first formula. So that's how you derive the first one. Again, the other two are basically the same proof, just relabel things. Okay, so let's actually apply the formula. That's what I want you to mainly be able to do. It's nice, but this just kind of shows you where it comes from and why it works. Oh, and one other thing I should mention before I forget. Notice that this part here, not this part, looks sort of familiar, I hope. It is basically the Pythagorean Theorem. And if alpha, beta, or gamma is 90 degrees here, cosine of 90 degrees is 0. And then this side is the side opposite the 90-degree angle, so these would be the hypotenuse, these would be the legs. You know, just you're used to seeing it like this, but these are just relabeled different letters, right? So these would be the hypotenuse, these would be the legs of the triangle, and then these are 90 degrees. So my point is, the law of cosines is really just a broader version of the Pythagorean theorem. If alpha, beta, or gamma are 90 degrees, these reduce to the Pythagorean theorem. And that might help you memorize the formulas, right? Because we all know the Pythagorean theorem. This would be, of course, the side opposite of this angle, but otherwise this part looks just like the Pythagorean theorem. Right. Don't forget when you're using these formulas, this is minus 2 BC, AC, AB, whatever the sides are. All right, so let's go ahead and do some problems. So again, usually you're just given the information and not a picture of the triangle. Of course, you might be given a picture as well in your homework, and that actually makes it easier. So we have gamma given, 75 degrees. Whoops, that's alpha, not gamma. And then A and B are not across from gamma. You need to have C. So A is 21, B is 15, and C is what we don't know, right? And we also need alpha and beta. So this, because we don't know an angle and a side opposite, we need to use law of cosines. This is the SAS case. So in this SAS case, you always have to find the side across from the angle first. You can't find alpha or beta because you don't know C, right? There would be two unknown parts. The only one of the formulas where you know all parts but one will be the one with C squared isolated. So we're going to use C squared equals A squared plus B squared minus 2AB cosine gamma. So C squared equals 21 squared plus 15 squared minus 2 times 21 times 15 cosine of 75 degrees. So these are calculator problems. You really need a calculator to do them. And we will approximate, but we don't want to approximate until the last step. So if you plug this all in, don't round it and then take the square root of the rounded answer. Take the square root of that decimal number that you didn't round. So C will be the square root of, and I'm going to plug this in and get this number here. But when I write it down, I'm not going to approximate. Make sure you're in degrees. Better make sure. Okay. So 21 squared plus 15 squared minus 2 times 21 times 15 cosine 75. Okay, so 502.944. Instead of rounding, I'm just going to put ellipses. That just shows that there's more and you haven't rounded. And then take the square root of that. So that's C is approximately 22.4. Now we need to find alpha or beta next, right? The sides across from our given sides. And you can use the law of sines or the law of cosines at this point. I always use the law of sines if I can, so that's what I'm going to switch to. So I'm going to find alpha next. So sine alpha over 21 should equal sine, and so the ratio I know is gamma and C. Sine 75 degrees over C is 22.4. But actually what I'm going to do, because this number is on my calculator and I haven't rounded it, that's actually what I'm going to use for my calculation, because the less rounding you do, the more accurate your answer is. Every time you you round this, now and then you get an answer and you round it again, you've got more round off error, right? So I'm going to use this, it'll give me a better answer. So in your homework, if you feel like you really are doing it right, two things to check. First, make sure you're in degree mode, not radians, right? If the angle's in degrees. And then the next thing, your round off error. If you're rounding too much, that can affect your answer. Okay, so 22.4 sine alpha will equal 21 sine 75. So sine alpha will equal 21 sine 75 degrees over 22.4, right? And just put the ellipses down. So 21 sine 75 divided by, and then I can just use answer, equals 0.904. And then take the sine inverse. So alpha is approximately 64.8. And from there, now you might be thinking, well, there's actually two angles that have this sign, but if you do 180 minus that, 115, that's going to be too big for the 75 degrees. This is not an ambiguous case. This triangle is determined. If this angle is fixed and this is fixed and this is fixed, this is determined. And there, you really don't have any situation where you're going to get two triangles. So there's alpha, we've got C, and then beta will just be 180 degrees. Whoops, I need to make sure I label. I'll take a half a point or a point off if I forget that, because otherwise it's radians, right? Okay, 180 degrees minus 75 degrees minus 64.8 degrees. So that is 40.2 degrees. So beta is approximately 40.2. And we've solved that triangle. Okay. So now we're going to do one more problem. I think just one more. And then a word problem. Okay, so in this one, notice this is side, 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 SSS case. And this is really important to pay attention right here. When you solve the side, side, side case, of course you have to find an angle. You know all the sides. Always solve for the largest angle first. Especially if you're going to switch to law of sines, because with law of sines, like we had here, right, there's two. We talked about how there can be two angles that have the same sign. So we don't know if there's going to be an obtuse angle or not. The law of cosines will determine if your angle is acute or obtuse with no ambiguity. And we'll talk about that when we do the math. If you don't solve for the largest angle first, then you don't know if you have an obtuse angle or not using law of cosines. You switch to law of sines, and then there's some ambiguity there. You're not sure which is it, the acute or the obtuse that you should take. So you have to be careful. If you use the law of cosines, there won't be an issue. I'll show you why. The math will not lie to you, right? Let me adjust this a little. There. So, of course, you can tell which one's the biggest because it's going to be across from the largest side. So solve for gamma in this case, or C if you cap C if you want to call it cap C. So we're going to say c squared equals a squared plus b squared minus 2ac, or ab, excuse me, cosine gamma. So c is 12.5 equals 5.1 squared plus 8.2 squared minus 2 times 5.1 times 8.2. And then gamma is what we don't know. So in here we need to isolate cosine gamma. So you got 3 terms, 1, 2, 3. Move these terms over by subtracting. And if you want, you can multiply these, or you can just leave it. And we're going to divide to isolate cosine gamma, -2 5.1 times 8.2. So, right, this is all going to cancel. You're going to have cosine gamma equals whatever number you get here. Be careful when you plug this in your calculator, and you can, do some of this in more than one step. I'm going to do it all at once. So I'm going to use parentheses. So 12.5 squared, make sure I got this on the screen. Oh, good thing I looked. That's 1.25. Parenthesis, 12.5 squared. Ugh. What am I doing here? This is a new calculator. I'm going to blame it on that, even though it's me. 12.5 squared minus 5.1 squared minus 8.2 squared. Parenthesis, close it off, divided by, parenthesis, -2 times 5.1 times 8.2. And you can do this on the same exact steps on the TI-30. So see how that's a negative number? I'm just going to use ellipses. I'm not going to write all the decimals. Equals cosine gamma. So gamma is the cosine inverse of that number. So if you think about an angle in standard position, cosine is positive in quadrant 1, negative in quadrant 2. So if this number is negative in here, this is going to be an obtuse angle. If it's a positive, you've got the acute. So the cosine, law of cosines, using cosine inverse, you'll be able to determine with the math, without even thinking about subtracting from 180, that you've got an obtuse angle. This has to be obtuse because of the negative. So the sign is very important. If you get the wrong sign, you're going to get the wrong angle. So, whoops, I want to do cosine inverse of the answer. So gamma is approximately 138.9 degrees. At this point, we need to find alpha or beta, law of sines or law of cosines. That's totally up to you. I'll grab another piece of paper so I'm running out of room. So I'll just find alpha first. Sine alpha over a is 5.1 equals sine, so I have to use gamma, that's the only angle I have, 138.9 degrees over c is 12.5. So sine alpha equals 5.1 sine 138.9 degrees. That almost looks like a decimal there. It's not. Divided by 12.5. So again, I'm just going to take the sine of the number on my calculator. If I had the TI-30, I would just do sine, hit my sine button of that. Here I have to use answer, right? And then take it times 5.1 and then divide by 12.5. So 0.268. And again, I'm not actually rounding that. I'm just going to take sine inverse of that. The less rounding you do in general, the better answers you get. Okay. So that is approximately 15.6 degrees. All right. Got the shakes. I can weird jerky numbers there. Okay, 15.6 degrees for alpha. And then gamma, I'll just write it down so we have them together here. We had that. And then beta will be, well, approximately, because I rounded these, 180 degrees minus 15.6 degrees minus 138.9 degrees. So 180 minus answer minus 138.9, 25.5 degrees. So there's my 3 unknown parts. And notice the biggest one is across from the longest side, right? And the smallest angle is across from the shortest side. That checks out. Okay, so SSS, solve for the largest angle first using the law of cosines. Then you're safe to switch to the law of sines for the second angle, and you don't have to worry about, oh, maybe this angle is acute or obtuse, I'm not sure, because you've already found the biggest one. You'll know if there's an obtuse angle or not. You can't have 2 obtuse angles in one triangle, right? All right, let's do word problem. So here we have some bearings. I didn't put any questions about bearings on the midterm. Well, I shouldn't say that in case I do that in a future course, right? So the semester I made this, I didn't. But that means for sure they're going to have something on the final. If I didn't test you on it on the midterm, you'll get tested on it on the final. So 2 ships leave a harbor at the same time. One ship travels on a bearing of north 35 degrees west at 15 miles per hour. The second ship travels on a bearing of south 50 degrees west at 10 miles per hour. How far apart will the ships be after 2 hours? Round the answer to the nearest tenth of a mile. Okay, so let's draw a picture here. So they're both leaving from the harbor. I'm just going to use H for harbor. And remember, bearings you measure from the north-south line. It says one ship travels north 35 degrees west. So you look to the north, measure 35 degrees to the west. And that is where, let's call that ship 1. The second ship travels on a bearing of south 50. Oh, this is, I went east, didn't I? I mix that up sometimes. I gotta go the other direction. I'm sorry. Erase that. My east and west, I do that a lot. Okay, so west is the opposite way. So this is our 35 degrees. Here's ship 1. And then the second ship is south 50 degrees west. So here's 50 degrees. I move this H because I'm going to put the angle measure in here. So here's H, or harbor, at 10 miles per hour. How far apart will the ships be after 2 hours? So we want to find D, this distance. And we know how far each of these ships has traveled because we know their speed and we know how long they've been going at that speed. So this one is traveling 15 miles per hour for 2 hours. So this will be 30 miles. Let me zoom in a little. I made my drawing so small. And then the second ship was going 10 miles per hour, again for 2 hours. So this is 20 miles. So notice this is side-side, and even though this angle isn't directly given, we can subtract from 180 to find this angle. So this angle right here will be 180 degrees minus 50 degrees minus 35 degrees, or 95 degrees. Right, 180 minus 85, yeah, 95 degrees. So this is a SAS case. There's other ways to solve this, but using law of cosines is the easiest way to do it. So we know 2 sides in the included angle. We want to find D. So D squared will equal these two sides, square them and add them up. 20 squared plus 30 squared minus 2 times 20 times 30. Let me zoom back out. Whoops, wrong way. There we go. Cosine of the included angle, which is 95 degrees. So we know all these parts. We will just need to take the square root, of course. So d will be the square root. I'm going to plug all this in the calculator. So 20 squared plus 30 squared minus 2 times 20 times 30 cosine 95. Okay, that's the number under the radical, of course. I'm not rounding that. Then take the square root of that. D is approximately 37 point, we'll just round to one place. Oh yeah, it says 1/10 of a mile. And that would be miles apart. A mile, so the ships are approximately 37.5 miles apart. So if we know the law of cosines, that becomes a pretty simple problem.